process, we then move to the final stage, which is full, i.e. the LSDB is complete. Okay, so those are the different processes, the different adjacency states of OSPF. So if I was to summarize it, we go from down to initialization to two-way to XStart, exchange start to exchange. We're exchanging LSRs, we're exchanging LSUs, we're exchanging LSA ACs, and then finally we're done, we're full. The only caveat to this is depending on your network type, there might be another step here where we have attempt. This is for non-broadcast but still multiple access networks. Okay, so if you're not allowing broadcast packets to be sent, you have to manually define the neighbor, and additionally you are sending out unicast hellos specifically to that neighbor IP address. So it's going to attempt to build that adjacency before moving into the initialization stage itself. Okay, hopefully that was a good summary, but let's put all of that into practice. Okay, so here we go. Here's the lab itself. So what I'm going to do is I'm going to configure an OSPF network, a very basic configuration between the ABR, which is the area border router between area 0 and area 1. So obviously it's going to have two different LSDBs, but we're just going to get the initial adjacency here into area 0 onto the backbone router itself. So let's go. So I'm going to log on to the VCP, which is the control plane for the virtual MX1, and there's absolutely nothing configured here. So let's go into the configure mode. That's fine. Yep, that's fine. I'm just thinking what that actually is itself. So let's go into edit protocols OSPF. Let's do show, and there's absolutely nothing there. And if I also do a run show interfaces terse, and it's just match on GIGI 0000, then what we can actually see is that the GIGI 00 interface, which is pointed to the backbone router, is up with the correct IP address. Can I ping the remote end? That's obviously very good to make sure in the very first place. So 192.168.2.2, and absolutely we can. So it's looking good apart from the OSPF configuration. Now let's bring the theory into it. So if I actually just run a packet capture on GIGI 00 interface on the backbone router itself, it usually takes a few seconds just to start up. And there we go. I said it takes a few seconds to start up. So let's now configure OSPF. So it's very easy to do on Juniper Junos. So let's do set area 000.0, or I could have just entered in area 0 for brevity. There's two different ways you could do it. And let's point it out the interface we want it to go out. So all you can do in Junos, you can actually do it two ways, because you can have multi-adjacency on the same interface, but you can define an interface, an outgoing interface, in this case GIGI 0000, or if you've got multi-adjacency on the same interface, you can actually define an IP address that you actually want to use. But let's just define this. Let's do a commit. Well, let's do a show, so you can see the very basic configuration. There's no authentication, there's no nothing. In terms of anything that might be mismatched and preventing an OSPF from forming an adjacency between neighbors. And let's do a commit check, make sure that configuration should pass, because it's obviously incredibly straightforward. And that's great. Now, what you should see as soon as I hit commit is we should see, once it's committed, some OSPF hello packets actually being received. There we go. So we're starting to see hello packets now. We're starting to see membership reports as well for 224.000.5. And that's an interesting point actually about OSPF. When a router first forms OSPF connectivity or starts trying to form an adjacency, if it sees no other routers for OSPF, it actually assumes it's going to be the designated router. It will just take membership, even if it's the lowest priority and not the more preferable one. But anyway, so let's stop the packet capture. And what we could see initially is the first hello packet. So we could see all the IP details, the Ethernet details. But if I actually go into the OSPF header, and what we can see is OSPF v2, so it's IPv4, it's a hello packet. Note the area ID, so this is the backbone, area 0000, area 0000, i.e. area 0, the backbone. We've also got authentication type, no, there's none. OSPF can have none, password, or MD5. And if we go into the OSPF hello packet, we can also see the network mask, hello interval, the dead interval, and those have to match between different OSPF neighbors. If they do not match, the OSPF adjacency is not going to work. And we've also got the priority. This is important when it comes to who's going to be the designated router, who's going to be the backup designated router as well. And as you can see right now, it's saying, I don't actually see anyone on this link as being the designated router. I don't see anyone on this link being the backup designated router because it's just the first hello packet. But maybe if I go to the last one we saw, we can actually see, on the very last OSPF hello packet, we can actually see 192.168.2.1, as I was saying, because it hasn't seen anyone else on this link in terms of being an OSPF router. It's assumed and just said, I'm going to be the OSPF designated router for this, what is essentially right now point-to-point link, but it won't be in a few minutes time, or in a few videos time, I should say. And it doesn't see a backup designated router as well. So this is really great information. But those are the hello packets. That's what's going to be sent out initially when you do the OSPF configuration itself. And so let's just come back to the ABR. And if I now do a run show OSPF neighbor, then guess what? It's still in the down state. And that's why I said during the whiteboard that the down state is not really a state, because what you'd expect to see here is some kind of neighbor down. But the ABR hasn't able to be to detect a neighbor itself because we haven't configured the backbone router itself. So OSPF, the adjacency down, it kind of is, but it's not really a state. It just means there's a configuration, but nothing's been received yet back from another OSPF router. Okay, so let's go over to the backbone router now. Let's configure OSPF, and let's actually see more of those OSPF packet types being received, sent, and actually exchanged between these two different neighbors. And let's see the OSPF adjacency actually being built. So let's go into the control plane of the backbone router. Let me just drag this down so you can see it. And here we go, we're on the backbone router itself. So let's do edit protocols OSPF. Let's do show, make sure there's stuff in there, and set area 0. Note I'm doing it differently just to show you it's a bit different. And note you can see the packets being, the hello packet still being received on Wireshark. Area 0 interface gig E 0 gig E hyphen 0/0/0. Let's do show, looks good. Commit to check, always good practice to do that. Make sure that the configuration is good before you commit it. And let's then commit it. So what you're going to see now, as soon as I hit enter, is you're going to see lots of different states of packets being sent, received. Let's just drag this down. There we go. Look at that. That is great, because what we can now see is that actual process, database descriptions, link state requests, link state updates, link state acknowledgements, update, acknowledgement, update, acknowledgement. And it keeps going back and forth. Obviously, this isn't a very complex network. There's nothing else configured, but that actually brings the practicality of OSPF building an adjacency into real life. But if we come back to the backbone router now, let's do run show OSPF neighbor, and there we go. So what we can see is that out of the interface with IP address 192.168.2.2, which is the gig E0 interface, it has got to the full state. So it has managed to exchange the link state database. Not that there's much really in there, and it's got this root ID of 1.10. So that's this router here. That is the backbone. Oh, so this is the ABR. Yeah, I was on the wrong one there. So that is saying that the IP address at the gig E0 interface, so the backbone router has this router ID with this priority of 128. So that's for the designated router. And again, if I come onto the backbone router itself, And if I do the same, run show OSPF neighbor, we can see that out of the GigE00 interface, the neighbor has this IP address of 192.168.2.1, and it has this router ID of 1111. And there's other different commands you could do. So I could do run show OSPF, and I can actually go into the database itself. And what we could see is what's being exchanged here. So from the ABR's perspective, I can see myself. I can also see the router LSA, which describes on the backbone router with that router ID 11110, what's connected to it, and the network itself 192.168.2.1. So that is actually the network, the point-to-point network really, that's connected between the ABR and the backup router itself, and it's been advertised by myself as well. So those are type 1 and type 2 LSAs, i.e. the router and the network. Router identifying who it is, what's connected to it, and the cost to get to me, and the network is identifying who that designated router actually is, and the ID to it. You can obviously go into more detail. So if I do this, go into router for area 0.0.0.0, then we'll actually go into more detail on those router LSAs as well. Okay, so there we go, bringing a little bit of theory on the different OSPF adjacency states. It does go very quickly though. You can see in a matter of seconds it went from down to full. It does happen very quickly, but we can also see the different OSPF packet types being exchanged, and how to do that on the Juniper Junos as well. Thanks for watching. On the next video, we'll be going through in more detail what is a designated router, what is a backup designated router, why do we have these, why is it important, why is it of benefit, and actually how can we configure those on the Juniper switches themselves. Thanks for watching. Goodbye.